Ya, Assalamualaikum warahmatullahi wabarakatuh. So, my name is Abdul Muiz bin Rahim. My metric number is 210177. So, I would like to present our project, which is a BJT and FET amplifier. So, now I want to uh, present my part is introduction. So the frequency response of BJT and FET amplifier is a frequency range area of the amplifier operation. The amplifier gain is affected by the frequency because the input and output of independence and capacitor used in an amplifier. There is a band of frequency in which a magnitude of the gain is either equal and relative close to the main band value, which is 0.707 AV. In the amplifier midband frequency capacitor, that is coupling and bypass in the connection appear as short circuit to alternate current AC, which is also considered the capacitor eligible. The frequency region below the FL cutoff frequency is called the low frequency region, and above FH is called high frequency region. Frequency response are used to illustrate the change in the gain and phase over a certain range of output signal frequency. So the diagram one below shows the frequency response of amplifier. So now we will discuss about the analysis and calculation.
My name is Muhammad Azul Hakim bin Uthman, metric number AA210032, and I will continue for analysis and calculation part. So for this part, we need to determine the transduce GM and GM out. So we need to sample our answer with the diagram of graph to find the Q point. So when we do the analysis, the capacitor will be the open circuit. So we start from finding what is VG. VG is a voltage drop from the RG2. So this is formula equation for find what is VG equals to VRG2. So we substitute the value resistor RG1 and RG2 to the equation and we get the value of VG. After that, in the loop, counterclockwise, we find the VGS and VRS. VRS equals to ID times to RS. Since the IS equals to RD, so this is actually VS IS times RS, so is equal to ID times RS. So we get VG minus VGS equals to ID times RS. So when the VGS equals to the 0, that's the formula equal to VG equal to ID times RS. So ID equals to VG divided by RS. So we substitute the value of VG and we get the ID value. After that, this is a graphical approach method. So we need to find the characteristic by using equation ID equals to IDSS bracket of 1 minus VGS divided by BP power of 2. So this is sketching to find the Q point. So this is a table reference point to find the Q point. After we sketch the graph, we get the VGS equals to negative 1.55 volt and the IDQ point, the IDQ value is equals to 3 milliampere. So after that, we find the value of transduce. So this is formula for GM equals to 2IDSS divided by BP and it's times 1 minus VGSQ divided by BP. So we substitute the VGSQ to this equation and we get the value of transduce and we find the transduce out. This is for equation question for reduce out, and we substitute the JM value, so we get the JM out. After that, for question B, we need to define the height cutoff frequency, FH in, then FH out. So for determine that, firstly, this is a SA equivalent circuit. So we find the impedance in equals to RTH. So to get the RTH, we get the RTH in the parallel. So this formula to get the RTH. So we substitute the RG1, the RG2 value. So we get the Z in equals to 99.1 kilo ohm. For Z impedance out, we know that the circuit is connected with parallel RD parallel with RD parallel with RL. Since the RD equals to infinity, therefore the equation become impedance out equals to RD parallel RL, and we substitute the RD and the RL value, and we get the Z out value. After that, we can find what is the value of the voltage gain. So formula for voltage gain is a negative JM parallel with times by parallel RD parallel RD and RL. So since RD equals to infinity, therefore the formula equals to negative JM times RD parallel RL, and we substitute the JM value that we get before, and we get the voltage gain equals to negative 7.83. For after you get the voltage gain, we use the voltage gain value to find what is the height cut-off frequency in and out. So for cut-off frequency, due to C in, capacity in, FHI. So this is formula what is capacity in. So we substitute this value already given in the question. So we need to find what is CMI. So CMI equals to bracket 1 minus voltage gain times by capacity GD. So we substitute that value and we get the CI. So after you get CI, we substitute to the frequency equation, which is frequency equation with 1 over 2 pi RC, which is the R is the resistor across the capacitor. So we substitute the R is actually parallel with RSIG. The RTH parallel with RSIG. So we need to calculate the RSIG parallel with RTH. So it become like this. And we substitute the CI value and we get the frequency height in equals to 633.46 kHz. So for FHO, due to CO, so this is formula CO. So we need to find what is CMO equals to 1 over 1 divided by voltage gain times CGD, and after we get the CO, we substitute the CO value into the frequency height equation, After that, we get FHO. So the dominance of the high cut-off frequency, which are the lower frequency. So as we can see, the lower frequency after we calculate, the dominant is 633.46 kHz, which is FHI. So for the part C, the question need to find what is the low cut-off frequency for each capacitor CG, CC, and CS. So this is a AC equivalent circuit. So due to CG, frequency to the CG, so the CG, the resistor, as we know, the resistor is across the capacitor. So we need to plus the RSIG to an RTH, and we substitute the CG value, and we get the FLG equals to 1.0 So for the part C, we need to find the load cut-off frequency due to the capacitor CG, CC and CS. So we find the FLG due to CG. So the resistor across the CG is RSIG plus RTH. So after we calculate and substitute the CG value, we get the FLG equals to 1.49 Hz. After that, we find the FLS, which is the frequency due to CS. So the resistor is a little bit different. We need to calculate the GM parallel with RS. So we calculate the total resistance across the capacitors, which is CS. So we get the total resistor is 304.57 ohm. And after that, we substitute into the frequency quotient, and we get the FLS value equals to 237.53 Hz. So for next, we need to find FLC, which is the frequency due to capacitor CC. So the resistor across the CC is RD plus RL. So we substitute the CC value and we calculate the total resistor across the capacitor, and we get the FLC equals to 1.65 Hz. So the dominant of low cut of frequency is 241.14 Hz, which is the dominant, which is the highest frequency of low cut off.
My name is Nuriwana Haida binti Muhammad Isri. My metric number is AE18003, and I will explain for the discussion. Okay. In order for the physical world and electronic device to communicate with one another, analog circuits are used to amplify, process, and filter analog signal before converting them to digital signal, or the other way around. But most real-world signal are an analog signal, so analog circuits are an essential part of most electronic systems. In many applications where signals are derived from analog sensor and transduced before being converted to digital signal for further storage and processing, analog electronics are still commonly employed in radio and audio equipment. So in this activity, DC and AC analysis is used to answer questions in this activity. The DC analysis is necessary for power supply and its limitation, the current consumption, and to ensure that all of the circuit components are operating within a safe range without going over their typical rating. It also can determine the circuit bandwidth, low cut-off frequency, gain roll-off, and any peaking from the frequency response obtained from the AC analysis to measure the rise or fall time, slew rate, and many other characteristics such as quality factor in the time domain. Transient analysis must be performed.
Okay, so my name is Amza Azril bin Amruddin, and my metric number is CE210143. Okay, so for the conclusion, we learn many things about the frequency response of BJT or FET amplifier, which is the range on the amplifier will operate the negligible effect from the capacitor and device internal capacitance. Moreover, the concept of this project is to focus on finding the low cut-off frequency for each of the coupling, CG, CC, and bypass, CS capacitor, and identify the dominant cut-off frequency. So we were able to find the value of the coupling, bypass, and the dominant cut-off frequency. Furthermore, by using the correct formula for the frequency height input and output, the value, we were able to find the cut-off frequency. So lastly, we also learned how to use the knowledge that we had learned during the class and did some research on this project to figure out the answer for given question. It will also be a great thing because we work this out together to finish this stuff before the due. Okay, so that's all from me. From us. Thank you.